Okay, now we're going to start talking about antiderivatives, and the process of taking an antiderivative is just the reverse process of taking a derivative. So the idea is before we were given f of x and then we were trying to find f prime of x. Now what you're going to do is be given f prime of x, and we're going to go back to go back to that original equation, or the equation I try to think of it as above it. Okay. When we put these equations in order, like if I give you f of x, the derivative would be f prime, the derivative of that would be f double prime, and then going backwards would lead you to the equation above. If I give you f of x and we want the equation above it in this setup, we would call that big f of x. Okay, so here's the first problem I'm going to look at. So if I give you f of x is 2x, what would big f of x be? So the idea is if you take the derivative of this equation, you should get to 2x. The easiest one that people come up with is x squared, right? So the derivative of this would give me 2x. So that makes sense. But notice here, I can also do x squared plus 1. This would also give me 2x as f of x, that derivative. Or really, I can do any number there. So the idea is an antiderivative can be, for this particular problem, could be x squared plus any constant. And that c could be a positive or negative number. And let's think about graphically why it makes sense. Well, here's x squared. Let's draw a rough graph of x squared plus 1 and maybe like x squared minus 2. So that plus c, all it does is move that graph vertically. But notice at every single x value, they share the same slope. Here, the slope is always 0 because it has a horizontal tangent. And then if you look at the same x value, let's say that's 1, if you draw a tangent line, notice those are all parallel. Because at the same value of x, the slope is the same. So it makes sense that all of these would create the same derivative graph. Okay, a couple of vocabulary things. So when we take an antiderivative, this is the symbol. It's actually called an integral symbol that we used when we want to take the antiderivative of f of x dx. So when you see that symbol, it's called the integral sign. That's your notation telling you that you want to take that antiderivative. The entire thing with the symbol, the f of x and dx, is called an indefinite integral of f of x. The f of x piece is called your integrand. The dx piece is your variable of integration. So this should always match this variable. And then the plus c that you end up with in your answer is called your constant of integration. So let's just try to see if we can come up with these three antiderivatives or indefinite integrals, thinking about what we know. Okay, so I want the antiderivative of x to the fourth. So when we took the derivative, basically we're just doing all the reverse processes. When we took the derivative, we bring the power down and reduce the power by 1. So if I take the antiderivative, it makes sense that we should add or increase the power by 1. But if I just have this, the derivative of this is just 5x to the fourth, but this is just x to the fourth. So remember when we took the derivative, we bring the number down and multiply it. So the reverse process would be dividing by that number. And we just talked about that. Really, the antiderivative can be a whole family of functions. It's x to the fifth over 5 plus any constant. Now you can check your answer by taking this derivative. The derivative of this function, leave that 1/5 out, would be 5x to the fourth. And notice we get back to the original problem. So you can always check your answers by taking the derivative and see if you get back to the original. So what if I take the derivative will get you back to cosine? Well, this one would just be the sine. And here, using the same idea that we did over here, so remember we increased the power by 1, so instead of -3, it's going to be a -2. Instead of multiplying by that number, we're going to divide by that number. So this would look like this.